Applications of differentiation. Finding the nature of turning points. Find the turning points of this cubic curve and then determine the nature of those turning points. What we need to understand first is that at the turning points, the derivative or the slope function equals 0. So the first thing we need to do here is differentiate this cubic curve, giving a quadratic. So we multiply by the power, reduce the power by 1. So the slope function is 3x squared minus 18x plus 15. Now if this equals 0, as it does at the turning points, we have a quadratic equation to solve. So dividing across by 3 simplifies this a little bit. And we see the factors then will be x minus 5 and x minus 1, giving solutions x equals 5 and x equals 1. So if we sub these values into the original curve, into the cubic, it gives corresponding y values. So sub in 5 for x, we see an output then that y is equal to negative 25. So our first point is x is 5 and y is negative 25. And then we sub in x equals 1 into the curve. We see this evaluates to be 7. So the second point is 1, 7. So these are turning points. We've answered the first question, but then we're asked to find the nature of them. That means, are they maximum or minimum points? Now we actually could tell this already by just looking at it. We can see that the nature of a quadratic cubic, we can see the one obviously with the highest y value, that's the maximum. So the 1, 7 is a maximum, and the 5, negative 25, that has to be a minimum just by comparing the two of them. And we could see it from the shape of the curve as well. However, to formally prove this, because the curve we're being asked mightn't be as straightforward as the cubic curve that we recognize. So the formal way to recognize a maximum is at a maximum the second derivative would be less than 0. And at the minimum the second derivative is greater than 0. So this is the formal way of finding it. So we have our first derivative here, I put it in yellow. We need to differentiate this a second time. So again, we multiply by the power, reduce the power by 1. This will give a linear equation from our quadratic, or a linear expression, 6x minus 18. So we're asking a question, when is this linear greater than 0? Well, we're going to check our points. So we know that our x value is 1 for one of them. And if we sub 1 in for x here, we see it gives an output of negative 12. Negative 12 is less than 0. So that means when the x value is 1, that must be a maximum as opposed to a minimum. So that's the proof that that's a maximum. And we do the same with our other x value. If we sub in 5, this time we see we get an output that's positive. So we have an output of 12. And since this is greater than 0, that means 5, negative 25 must be a minimum. So what we've learned here is that if you want to check if something is a maximum or a minimum, what you do is you sub in the x value into the second derivative and see is the output positive or negative.